Okay, this is problem one of homework three. It is a bent rod, and this geometry actually we generated in class maybe a couple of weeks ago. But now what we want to do is to clamp the bottom of it and apply a force like that, which make this thing actually torque. Now the material properties I'm giving you these values, but I will use the default material properties that are in the Catia program, okay? So they're slightly different from these, but that's okay. And the other thing is that the, in order to do this problem, this is not the most appropriate element to use. Probably beam elements are better, more efficient. Of course, I want this thing to be done with solid elements. We haven't covered beam elements yet. And the other thing is that if you're looking for stress distributions, you cannot get it within CATIA for beam elements, okay? So we're going to use solid elements there. Now the cross-sectional area, cross-sectional radius is 1 inch. So these are all in inches. So let me start with a part file, and immediately I'm going to save this thing file, save management, save as, and I have a folder here which is under homework 3. Uh, why don't I call this thing problem 1? Problem 1, homework 3. Okay. All right. So on a convenient plane, on that horizontal plane, I will sketch a circle, radius 1. So dimension it with this icon, diameter 2 or radius 1. Okay, exit. Now, since I have to rib this, or other packages may be calling a sweep or extrude, since I'm going to, Katia calls it deep, I need a center curve there. So on that vertical plane, I'm going to sketch a curve, which will actually be the spine, or Katia calls the center curve of my geometry. So let's see now, we'll have some dimensions. For example, the dimension from here to there, I believe is 8 inches. Let's try it again. From that point to this line, this is going to be 8 inches. And there are different ways of doing the problem, by the way. This is my way of doing it. So, and from this point to that line, that is, if I'm not mistaken, 5. Double click on it, 5. And the radius of this bend is, I'm specifying it to be 1 in the drawing. Good. Exit. And now we can do the rip operation. So uh, look on the sketch-based features. There is a rip here. Now make sure that make sure that cancel that. Make sure that the curve is not selected. Just click on anywhere on the screen. So rip profile is the profile that you want to sweep is that circle, and the center curve is right there. The reason I said that make sure nothing is selected, because sometimes that orange curve is selected and you try to make that profile by accident, and of course you can't do it. That's all. All right, let's apply material properties, steel. So here's the apply material, metal, steel on that part, and it doesn't matter what you pick, basically it puts it on the entire part. Good. So you can see that. If you want to change the material properties, you can go and double click on it. Okay. Incidentally, uh, let me undo this, because I want to show you. Remember, I took this piece. I took something from here, and I put material properties steel on it. Let me undo this or show you something. So what happens if you repeat this? again, metal, steel, and you put it there. Notice that the position where it's coming is going to be different, but it is steel. And if you want to change this thing, double click on steel. The problem is that if I do it on this laptop, it crashes, but it won't happen to you at the university. Okay, so double click and change it accordingly. But this is fine. So let me save this, and then I'm going to go start analysis and simulation, generative structure analysis. These are the two modules that essentially deal with finite elements in Catia. So far, we have not touched that top one, but that's only for meshing purposes. And I'll do generative structure analysis. The default analysis is static. That's good. You can look at your mesh, put the cursor on nodes and element, right-click mesh visualization. There it is. You can refine the mesh in different areas if you want, but I'm not going to do that. By the way, if you double click here, it says that you're using parabolic element. There's also the choice of using linear element, which are less accurate, but for these problems, it doesn't matter. This is just to demonstrate. We are not assessing anything about accuracy in this course, at least right now. Okay, good. So automatically, by the way, 3D properties are used when you do automatic meshing like we did. And so let me deactivate this, because while this is in front of us, there's nothing we can do. If you don't like the rendering here, you can change this thing to, what is that, shading with edges. If you want to see the edges, okay, I think it's the third one. Maybe check that. Yeah, that one of them was without edges, the other one with edges. Now, the bottom is clamped. So for clamp, you look at the restraints toolbar, clamp, surface slider, along with other stuff, by the way. And this one, user-defined restraint, that we already use it. And I haven't talked about this anchor. So let's do a clamp. And you're asked to clamp the bottom surface. Now you can select the edge, but that's not going to be the bottom surface. I'm just going to put it on only on the edge. I said clamp the bottom surface, so please select the entire surface, not the edge, because these are different things. And then the force, here's the force on that face in the direction X, 2,000 pounds. 2,000, my units are already in pounds, so, and this of course has to be 0. And there we are. Now, if you want to push it in the other direction, no problem. Just put a minus sign, flip the arrows. It goes in the other direction. Now, notice that there is no plane of symmetry here. If I was applying this load in the y direction, this will bend, it will not twist, and then you can use there is a plane of symmetry that you can use, but that's not what we have. That's pretty much it. So let me save this thing. File, save management, analysis not save, save as. Yeah, this is homework 3. Okay, so I'm going to call this thing problem 1. Homework 3. It is so important to name these things so that you don't lose them, you don't overwrite them, etc. Now go get the compute icon, which looks like a calculator. Click on it, run it, and done. So here's the general deformation shape. Click on it, you can animate it. Okay, very good. You can look at the displacements. You click on the displacements, and it'll give you in inches right there. If you want to move this thing, just select it and drag it. And once you're done, you select it again. If you want to see color contours, so click on this contour or from the tree. Every time you generate something, corresponding thing is created. And select the visualization tab, average ISO. Okay, the contours are plotted here, except that they're line drawing, so you can change that to material shading from rendering, and it looks like that. And remember, if you want to see your element mesh 2, just go to the very bottom. Under rendering, go to very bottom, and you'll come. And there are other things you can do here, but that's all. Now look at the one meter stress over there. We are not like, assessing accuracy here because notice that the regions of big stresses are either here or there depending on the relative sizes of these two pieces. Incidentally, let me select my legend. You bring it here. When you're done, you deselect it. Now, the reason that you may want to move this thing because you can zoom in and out, select it again, use the usual zoom in and out. You can move it around. When you're done, click on it. The other thing is that notice that these colors are all smooth. So if you double click on it, if you left double click on it and say under more, under more, uh, actually, that's interesting because I thought it was here. Let me see for a second. Let me try one more time. I'm not sure, but I'll find out where it is and let you know. But I thought that you could change this thing to, instead of smooth color changes, to a different way of, abrupt color changes. So I thought it was here, but let me see one more time. Oh, yeah, well, let me click on this. Ah, there. Okay, cancel. Yeah. You click on these three dots, and instead of smooth, you uncheck it, say okay, and apply. Notice that the colors change here so that there are abrupt color changes, and over here too. Incidentally, you know that you can cut this thing if you want with a cutting plane and see the stress distribution inside. You can move this thing up, turn it around. You can look at the stress distribution inside. And if you don't want to see this plane, cutting plane, you can just say, don't show me the cutting plane. And you can do all kinds of things with this. All right, very good. So let me stop this thing.